Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. 27x square into e to the power 3x, right? So what we've been given is dy by dx and we've been asked to find y. So my y is nothing but integral of the given expression. So let's write down what is our y. My y is integral of 27x square into e to the power 3x dx. That's my y. Now I know that 27 is a constant, so I can pull out the 27 in the given expression. So I can rewrite my y as 27 times integral of x square into e to the power 3x dx, right? So for the next few minutes, we're going to deal only with integral of x square into e to the power 3x dx. Now we've seen enough and more problems for us to assess whether a particular integral can be solved by using integration by substitution or integration by parts. Now, this is very clear that, I will have to solve this using the method of integration by parts. So, what does my integration by parts state? Integral of u dv, whenever I have an integral of the format u dv, then that is equal to uv minus integral of v du, right? So the key to solving this problem is identifying the right u and v, right? Like I mentioned earlier, my 27 is kept aside, so my LHS for now is integral of x square into e to the power 3x dx, right? What is our u, what is our v, right? Now my u can be x square or it can be e to the power 3x, right? Now, whenever you have something of this format, integral of u dv, and you see x to the power n there, my suggestion is choose u equals x to the power n, right? And of course, this is not a mandate. My suggestion is you try out both the combinations and see which one works for you better. But in these type of problems, you will always see that u equals x to the power n works out well for us, right? Now we will see why in the subsequent steps. I'm going to write down my u. My u is x square, which means my dv is e to the power 3x dx, right? Which means my du is 2x dx. My v is nothing but integral of e to the power 3x dx is nothing but e to the power 3x by 3. Right, now we'll reserve our constants towards the end. Now I go back to my u dv integral. I have my u, I have my v, I have my du, I have my dv, right? Now, what is my uv? My uv is nothing but x squared into e to the power 3x by 3, right? And then I have minus of integral of v du, right? So what is my v? It is e to the power 3x by 3. So I'm going to pull out that 1 by 3 outside the integral, right? And then I have my integral of, I will have the e to the power 3x part of v, which I write it as it is, right? Which is e to the power 3x. And then I have my du, which is nothing but 2x dx, right? So I can pull out the 2 here as well. Means I'm left with integral of e to the power 3x times x dx, right? And it's better if we write it like this, right? So that's my expression. Now, if you see some of the earlier problems, what we solved under integration by parts, we arrive at our uv and we arrive at our integral of v du, and we see that my integral of v du is in a very simple format whose antiderivative I know by first principles or any of the identities we have learned so far. But in this particular expression, I see that my integral of v du is still of the form 2 by 3 times integral of x into e to the power 3x dx, right? So what does it call for? It calls for again an application of integration by parts, but this time we're going to apply it on integral of x into e to the power 3x dx, right? So I'm going to write down my u v du dv, right? Now let me differentiate the first substitution, what we made with a different color, right? And my yellow corresponds to the substitution what we made for x square into e to the power 3x dx. And then let me highlight my x into e to the power 3x dx using a green color, and whatever the substitution that I'm going to do now will also be highlighted in green. So my u equal x, my dv equals e to the power 3x dx, my du equals dx, and my v equals e to the power 3x by 3. Let's highlight this in green. I'm going to treat integral of x into e to the power 3x dx separately, and we will come back to this particular expression, right? So I have integral of x into e to the power 3x dx. Again, I apply the integration by parts. So what is my uv? Refer to the green expression. The u is x, my v is e to the power 3x by 3. Therefore, my uv is, right, 3 minus of integral of v du, right? So what is my v? My v is e to the power 3x by 3. My du is dx, right? So I get 1 by 3 times integral of v du, which is nothing but integral of e to the power 3x dx, right? So let's write that down. Now, do I know the answer for integral of e to the power 3x dx? The answer is yes, I do know it. Therefore, let me go to the next line. I do not have to do any further simplification as far as integral of x into e to the power 3x is concerned. So my integral of x into e to the power 3x dx equal to x into e to the power 3x by 3, which is my first part, minus of 1 by 3 times integral of e to the power 3x dx becomes e to the power 3x by 3, which is 1 by 9 times, because I already have a 1 by 3 outside, 1 by 9 times e to the power 3x, right? Now I go back to integral of x square into e to the power 3x dx, right? So let me rewrite what I have. Integral of x square into e to the power 3x dx equal to x square into e to the power 3x by 3 minus 2 by 3 times. Okay, this is where I want you folks to be very careful, because when you are successively applying integration by parts, there is a high possibility that you might miss out on some of the numbers that come along with you in the integral, right? So be very careful and treat every step with care, right? Now I go to my integral of x into e to the power 3x dx. I have x into e to the power 3x by 3 minus of e to the power 3x by 9, right? So I open my bracket, and this is what I get, right? Now I know that I can do a little bit of simplification, so let's do that. My first part of the integral remains as it is, and my second part, I get 2 by 9 times x into e to the power 3x, right? So let's write that down. 2 by 9 times x into e to the power 3x, plus I have a 2 by 27 times e to the power 3x, right? So this is what I get. This is my answer for integral of x square into e to the power 3x dx, right? Now, remember that this is not our y. My y was 27 times integral of x square into e to the power 3x dx, right? So, let us go back to our y and write down what is our y. My y equals 27 times, right? So, this is what I get for my y, and then I have my constant, right? I know that I can do a little more of simplification, so let's do that. My y becomes equal to, my first part of this expression becomes 9 times x square into e to the power 3x minus of 6 times x into e to the power 3x plus 2 times e to the power 3x, right? Plus c, right? So this is what we get. My y equals 9 times x square into e to the power 3x minus 6x into e to the power 3x plus 2 into e to the power 3x plus c, right? So this is a good example of how we can go about solving a problem, applying integration by parts successively, right? And in the next few videos, you will probably see how we will be applying integration by parts more than twice, right? In this particular problem, we applied it twice. In the subsequent problem, we'll see a problem where we will be applying integration by parts more than twice. And how do we generalize this and use the Bernoulli's identity of integration by parts to solve similar problems, right? I hope you found my content useful. Please do subscribe to my channel and support. Thank you.